So welcome back students to one more session of your general organic chemistry. So in the previous video I've taught you what is the concept of mesomeric effect. That means what did we learn? We said it is a complete transfer of pi electrons, or you're going to transfer a lone pair of electrons. Where are we going to transfer? We're going to transfer towards an electronegative atom. That is what we have learned. Today in this video we are going to learn the types of mesomeric effect. So basically we have two types of mesomeric effect. One is plus M effect and one is minus M effect. Let us divide the page into two equal halves. Right. So plus M effect in groups and minus M effect in groups. So in plus M effect, what is going to happen? The electrons are transferred towards the conjugated systems. By whom? By electron releasing groups. Once again, I said there is complete transfer, but here important, in plus M effect, electrons are transferred towards the conjugate system, where there is what are conjugate systems? This is alternate sigma and pi bond, isn't it? Towards the conjugate system by electron releasing groups. Okay, those are called as plus R groups or plus M groups. Okay, what are the examples? Means here electrons will be transferring towards the conjugate systems. Which one will do this work? Electron releasing groups will do this work. Right? Right. For example, alkyl groups are electron releasing. NH2 electron releasing, OH electron releasing, NHR are electron releasing, NR2 electron releasing, and OR electron releasing. Okay, right? Fine. So these particular thing, all these examples, electron releasing group. I'll be showing you with an example, then you'll understand. And you know, whenever these groups are present, the central atom, whatever is there, has a lone pair of electrons to donate. That is what it donates. That's the reason it keeps donating. And whenever there is a plus M effect or plus M or electron releasing groups, what are where will they direct? They are always ortho and para directing groups. All these are ortho and para directing groups. Remember this. So when they are ortho and para directing group, what will happen? It will increase the stability of the molecule. Increases the stability of the molecule. Remember that. Now when I come back to minus M effect, here it is different. Electrons are attracted from the conjugate systems to the electron withdrawing group. Here what do we say? Electrons are transferred towards the conjugate system. I said towards. Now this is away from the conjugate systems. Let us write that. Electrons are attracted from conjugate systems. Which was attracting? By electron withdrawing groups. Electron withdrawing groups. This is electron releasing groups. This is electron withdrawing group. What are the examples? So these are called as minus M groups. Examples. What are the different examples? OR2 plus cyano, CX3, COOR, SO3H, NO2. All these are electron withdrawing group. All these groups are meta-directing groups. Meta-directing groups. So when it is meta-directing, what will happen to the stability? Stability automatically reduces, isn't it? The stability decreases. When such groups are present, they reduce the stability of the particular. So that's why we call this minus M effect. Right. Let's see. Now I said plus M effect and minus M effect. Let us take an example and explain. So when such groups, let me take one example with R. So what am I showing? I'm showing you plus M effect first. I told you example. Here I'm going to take an alkyl group. So I'm going to take a benzene ring and I'm going to show you with CH3. Now CH3 is an alkyl group and this is called toluene. So when such groups are attached to benzene ring, these are our plus M effect groups. What will do? They will increase the electrophilic substitution. Right? What are they doing? They are ring activating groups. They will because they keep donating the electrons, isn't it? They're ring activating. Which direction they activate? Ortho and para directing. Right? So they start increasing the electron density at this position. Let us see certain listen the resonance of this by drawing the chemical structures. Let's start. How do they do? First, in the first step, this bond is going to shift here. Okay, let me take in the other way. Let me not take like this. Let me take in this way so that it's easy for you. Okay, let me not do this. Leave this one. Okay, I'm sorry. Let me strike this off and come back again. Right. So, let me not confuse you all first. Benzene ring. I'll draw in this direction. CH. Okay, now this is right, isn't it? Right. In the first step, this bond shifts. Double and double can't be together. So this pi bond shifts here. So draw the chemical structure. How does this look? This one, this bond is going to shift. The electron density shifts here. At ortho position, you get minus. Fine, done. So here, let me finish off this. This has become double bond because the pi bond, sigma bond has shifted here. Hydrogen, and this is plus. Now in the second step, the electron density, now see here, you're creating a site for the electrophile to come and join here. Yes, because the electron density is more. Now this bond is going to shift here and this bond shifts here. So what do you get? You get minus minus, double bond, C, H, H, H. Now one more, this bond is going to shift here and this bond will shift here. This minus. Now see here. Now what's happening? These are all electron releasing groups or plus M effect groups. So whenever they are attached to the benzene ring, what will they do? They are creating, means there's a site for the electrophile, electron deficient. You're creating means the electron, because they're releasing electrons, and electron density, more of electron density is observed at the ortho position and para position. So that's why whenever electrophile comes and attacks at the ortho position, electrophile comes and attacks at the para position. That's why they are, what are they? They are ortho para directing groups. Ortho para directing groups. So whenever there are ortho para directing groups, what will happen to the stability? I said stability automatically increases. Correct? Right. Now let us come back and see minus M effect groups now. So minus M affecting groups. So we've already seen minus M affecting groups. What are they like? Cyano group, CX3, like the halogen, if the halogen is present. Correct? Let me take an example with CX3 and C. I have a benzene ring, pi electrons, and now I have an minus N group, that is electron withdrawing group with 3 halogens. Okay, right. So done. So first important thing, whenever I have minus M effect, that means electron withdrawing group means the more electronegative atom starts withdrawing electrons towards it. When this is withdrawing the electrons, this bond starts shifting because it tries to drag the electrons towards itself. Right. What do we get? We get a benzene ring like this. This bond is shifted, becomes double bond. Now this is C, X, X, and this is a negative charge. Now further, denoted by the double-sided arrow. In the next step, what happened here? The bond is shifted, so this becomes plus, isn't it? Now this bond is going to shift here because this has become deficient. So what do I get? I'm going to get this way, double bonded systems, conjugate systems we said, isn't it? This becomes X minus. So now the bond has shifted, so this attains a partial positive charge. And partial positive charge. Then to satisfy this bond shifts here. Now here there's a site created, so this becomes positive. Right. So when such groups are attached, what do? They decrease the electrophilic substitution, that is, they are ring deactivating. Okay, ring activating and meta-directing groups, they are also meta-directing. What do? Because of this, they reduce they decrease electron density to ortho and para positions. See here, ortho and para position, the electron density or electron is less. What will happen? On ortho and para position, there is electron density, means the electron cloud formation is less. But when the this will go automatically, it will direct it to meta position here. When it is directing it to meta position, what will happen? Meta position, it will destabilize the ring. Correct? Yes. So this is what is a concept. These are meta directing. Minus effect to M effect means meta directing groups, which will reduce the stability. Reduce the stability. Right. So thank you for watching, students. I'll come back with the next topic in my next video.